This is the Dive Into Discovery podcast, where curiosity meets insight, and every conversation uncovers a new layer of understanding.
Welcome to today's Dive Into Discovery. We're your hosts, Theo and Alex, and today we're taking a deep dive into the world of carbon capture technology.
Yeah, it's a topic that's been generating a lot of buzz lately. Some people are calling it, a climate savior, and others are saying it's a costly distraction.
Yeah, you gave us a ton of research on this, and it seems like there's a lot to unpack. Is carbon capture the key to a sustainable future, or are we putting all our eggs in the wrong basket? So let's dive in and see if we can figure that out.
Sounds good to me. Where should we start?
Well, I think first things first. We need to define what exactly carbon capture and storage is, or CCS. I know I've heard the term thrown around a lot, but I'm not sure I fully grasp all the nuances.
Sure. At its simplest, CCS is a set of technologies designed to capture carbon dioxide CO2 emissions before they enter the atmosphere.
Okay, so we're talking about preventing CO2 from reaching the atmosphere in the first place.
Exactly. And this capture can happen at various points. We can capture CO2 directly from industrial sources like power plants and factories, or even directly from the air.
Directly from the air. That sounds pretty futuristic.
It might sound like science fiction, but it's a real and rapidly developing technology called direct air capture, or DAC. Imagine giant fans pulling in air and filtering out the CO2. It's a pretty incredible concept.
Wow, that's amazing. But once you've captured all that CO2, what do you do with it?
Well, that's where the storage part comes in. The captured CO2 is compressed and transported, usually via pipelines, to suitable storage locations deep underground.
So we're talking about burying tons of CO2. It sounds like a bit of a risky proposition.
I understand those concerns, but the storage locations are carefully chosen for their geological stability. Think depleted oil and gas reservoirs or deep saline aquifers. These formations can hold CO2 for incredibly long periods, essentially locking it away from the atmosphere.
That makes sense. But has this technology actually been proven to work in the real world?
It has. In fact, the world's first large-scale CCS facility has been operating for almost 30 years. It's called the Sleipner Project, and it's located off the coast of Norway. They've been successfully capturing and storing CO2 since 1996.
30 years. If it's been working that long, why isn't CCS more widespread?
That's a great question. While Sleipner proves that CCS is technologically feasible, there are a number of factors that have hindered its wider adoption. One of the biggest hurdles is cost.
Cost is always a factor, especially when we're talking about such a massive undertaking.
Right. CCS requires significant investment in infrastructure, from building capture facilities to developing storage sites. And the energy required to capture, compress, and transport CO2 adds to the expense.
So it's a pretty costly endeavor. Some critics even argue that the cost of CCS makes it a non-starter, especially compared to investing in renewable energy. What's your take on that?
It's true that CCS can be expensive, but it's important to consider the long-term implications. We need to decarbonize a wide range of industries, including those that are difficult to electrify, like cement and steel production.
So you're saying that CCS could play a crucial role in those hard-to-decarbonize sectors?
Exactly. And remember, we're still in the early stages of CCS development. As the technology matures and economies of scale kick in, we can expect the cost to come down.
Okay, so cost is a factor, but it sounds like it's not necessarily a deal breaker. What other challenges are we facing with CCS?
Well, aside from the cost, there are also concerns about the environmental impact and safety of storing CO2 underground.
Those are valid concerns. I imagine people worry about the CO2 leaking back into the atmosphere.
Leakage is a risk, but it's one that can be mitigated with careful site selection, robust engineering, and continuous monitoring. Think of it like storing nuclear waste. It requires stringent safety protocols, but it's done successfully all over the world.
Okay, that makes sense. So leakage can be controlled. But what about public acceptance? Have you found any information on how communities are reacting to these CCS projects?
Public perception is definitely a challenge. People often have a not-in-my-backyard reaction, even if they support the idea of CCS in principle.
I can see how that would be a hurdle. No one wants a CO2 storage site in their neighborhood.
Exactly. And sometimes the fear of the unknown can be a powerful motivator. That's why education and transparency are crucial. We need to communicate the science clearly and honestly and engage with communities in a meaningful way.
So it's all about building trust and addressing concerns head on.
Absolutely. And it's important to remember that CCS isn't just about burying CO2. There's also the exciting potential of carbon utilization, where we can actually use that captured CO2 to create valuable products.
Hold on. Carbon utilization. You're saying we can take CO2 and turn it into something useful.
Precisely. And this is where things start to get really interesting.
I'm all ears. Tell me more.
Well, there are a number of ways we can utilize captured CO2. We can use it to produce building materials like concrete and aggregates, which helps reduce the carbon footprint of the construction industry.
So we're talking about literally turning CO2 into bricks and mortar.
Yes, exactly. And we can go even further. We can use CO2 to create synthetic fuels that can power vehicles and airplanes.
Wait, are you serious? We can make fuel out of CO2.
We can. And we can even use it to create everyday products like plastics and fertilizers. And get this, they're even using captured CO2 to make fizzy drinks.
Fizzy drinks made with captured CO2. That's wild.
It might sound strange, but it's true. And the possibilities don't end there. We can use CO2 to create a wide range of products.
This is incredible. So we're not just talking about mitigating the negative impacts of CO2. We're talking about turning it into a valuable resource.
Exactly. And that's one of the most exciting aspects of carbon utilization. It has the potential to transform CCS from a costly burden into a profitable opportunity.
That changes the game entirely. So you're saying that turning captured CO2 into products could actually make CCS profitable. This is a whole new dimension of this technology.
It is. And it's something that researchers and entrepreneurs are exploring with increasing enthusiasm. The potential for innovation in this field is enormous.
It sounds like carbon utilization could be a real game changer.
It could be. And it's an area that deserves a deeper dive all on its own. But for now, let's shift gears and talk about the connection between CCS and renewable energy.
Renewable energy, that's a topic I'm always excited to delve into.
Yeah.
What's the connection between CCS and renewables?
Well, one of the biggest challenges with renewable energy sources like solar and wind is their intermittency. The sun doesn't always shine, and the wind doesn't always blow, which can lead to fluctuations in energy supply.
Right, that's the issue of reliability with renewable energy.
Exactly. And that's where CCS can come in. By combining CCS with renewable energy, we can create a more stable and reliable energy system. Excess renewable energy generated when the sun is shining brightly or the wind is blowing strong can be used to power the carbon capture process.
So instead of letting that extra renewable energy go to waste, we can use it to capture and store CO2. Clever.
Precisely. This creates a sort of energy storage system where we capture and store CO2 when renewable energy is abundant and can then release it later when needed to generate power during periods of low renewable energy generation.
It's like a giant carbon-based battery for the power grid. I love that analogy.
And the synergy between CCS and renewables is increasingly being recognized as a key strategy for achieving a cleaner and more sustainable energy future.
It sounds like CCS has the potential to play a significant role in the fight against climate change. But let's zoom out for a moment and consider the bigger picture. Is CCS truly a climate savior, as some proponents claim, or is it just a costly distraction, as critics argue?
That's the million-dollar question, and like most complex issues, the answer isn't black and white. CCS has both enormous potential and significant limitations. It's not a magical silver bullet that will single-handedly solve climate change.
So it's not a case of either, but rather a matter of understanding where CCS fits into the broader climate solution puzzle.
Precisely. CCS can be a powerful tool in our climate toolkit, especially for decarbonizing industries that are difficult to electrify, like cement, steel, and chemicals. And as we've discussed, its potential synergy with renewable energy is immense. However, it's crucial to acknowledge that CCS is not without its drawbacks.
We've covered quite a few. The cost, the energy requirements, the potential for leakage, and the public perception challenges. It seems like CCS is a bit of a double-edged sword.
It's true. There are trade-offs to consider. But it's important to remember that no single technology is going to solve climate change. We need a portfolio of solutions, and CCS has the potential to be a valuable part of that portfolio.
So it's all about finding the right balance and using the right tool for the right job.
Exactly. And it's worth noting that CCS technology is constantly evolving. Researchers are exploring new approaches and innovations that could address some of the current limitations and make CCS more efficient, affordable, and scalable.
That's encouraging to hear. What are some of the most promising advancements on the horizon?
One exciting area of research is the development of new materials for CO2 capture. For instance, scientists are exploring metal organic frameworks, or MOFs, which are highly porous materials that can selectively capture CO2 from gas streams with remarkable efficiency.
MOFs, those sound pretty high-tech.
They are. And they have the potential to revolutionize carbon capture by significantly reducing the energy requirements and costs associated with the process. Another fascinating area of exploration is the potential for using volcanic rock formations for CO2 storage.
Volcanic storage. I've never heard of that. How does that work?
Well, certain types of volcanic rock, like basalt, have a natural ability to react with CO2 and convert it into solid carbonate minerals. Essentially, the CO2 becomes part of the rock itself, permanently locking it away.
Wow, that sounds like a pretty foolproof storage solution.
Yeah.
No risk of leaks there.
It's a very promising approach. Pilot projects like the CarbFix project in Iceland have already demonstrated the feasibility of this method, and it could potentially offer a safe and permanent way to store vast amounts of CO2.
It's incredible to think about the potential for these kinds of innovations to shape the future of CCS. It sounds like we're on the cusp of some major breakthroughs.
Absolutely. The field is constantly advancing, and it's an exciting time to be following the developments in carbon capture technology.
This has been an incredibly insightful deep dive into the world of carbon capture. Thank you so much for sharing your expertise with us.
It's been my pleasure. I always enjoy exploring these complex and crucial topics.
And to our listener, we hope this deep dive has provided a clearer understanding of the potential, the challenges, and the ongoing evolution of carbon capture technology. It's a complex topic with no easy answers, but it's certainly one worth pondering. As we continue to grapple with the urgency of climate change, innovations like metal-organic frameworks and volcanic storage offer a glimmer of hope for a more sustainable future. We encourage you to continue exploring this fascinating and evolving field. Thanks for joining us on this deep dive. It really does feel like we're at a tipping point with this technology. It's exciting to think about what the future holds for carbon capture.
I agree. There's a lot of momentum building, and I think we're going to see some significant advancements, in the coming years.
What did you think of this week's episode? We'd love to hear your thoughts in the comments. Don't forget to join us next time as we dive even deeper. And as always, stay curious, because you never know what discoveries are just around the corner.